In this video tutorial, we're going to define the terms strength and tone and help to clarify the differences because muscle strength is not the same as muscle tone. That has an impact on how we assess and treat neuromuscular disorders associated with the dysarthrias. So let's quickly go into a brief review from your A&P class probably years ago with muscle groups in the body. There are three major types of muscles in the human body. We have voluntary muscles, also known as striated muscles, also known as somatic muscles, also known as skeletal muscles. Four different terms to talk about the same thing. These are the muscles that we have primarily learned about in terms of speech and swallowing. Muscles like the diaphragm, the intercostal muscles, all of the laryngeal muscles, the suprahyoids, the infrahyoids, the muscles of the face, the muscles of the jaw, the muscles of the velum, the muscles of the pharynx. A second category of muscles in the human body is smooth muscles. We find smooth muscles in the GI tract and in the digestive system. The lower two-thirds of the esophagus, the stomach, the intestines are all made of smooth muscles. And then the third type are cardiac muscles, which we find only in the heart. Why is this important? Smooth muscles and cardiac muscles we do not have voluntary control over. Those are involuntary muscles that are regulated by the autonomic nervous system through the brainstem, spinal cord, and peripheral nervous system directly. You do not have voluntary control over those. However, the voluntary, also known as striated or skeletal muscles that we do know in terms of speech and swallowing, can be under voluntary control. In terms of speech, speech is a voluntary motor act, and so we will need to understand the voluntary neurological systems associated with voluntary movement to move our striated or skeletal muscles for speech. Swallowing, we know, has some voluntary and some involuntary stages. The neurological system associated with voluntary movement controls voluntary muscle movement for oral preparation and oral transit. However, we know that those voluntary muscles in the pharynx, larynx, and velum are also under involuntary subconscious control by brainstem-mediated responses in the nucleus of the solitary tract and the nucleus ambiguous. So the same muscles, voluntary muscles, can be under voluntary or involuntary control. That's a difference in neurological wiring. In terms of speech production for motor speech disorders, we are going to be focusing this semester just on the voluntary movement aspects for voluntary control. This is not the same as reflexes because reflexes are not under voluntary control. Those are involuntary responses to stimulation. So back to our striated voluntary muscles in the 5 speech production systems specific to speech. A lot of the literature in terms of exercise physiology is borrowed from our colleagues in exercise science, physical therapy, and occupational therapy. Heather Clark, in a beautiful 2003 tutorial article about neuromuscular functioning for speech and swallowing, reminded us how some of the speech voluntary muscles are different from muscles that control the limbs of the body. In the speech system, many of our muscles act as muscle groups, moving things like the lips, not as an agonist-antagonist muscle muscle pair like in the elbows and knees, but as muscle groups working together to achieve different postures with a wide range of postures available for structures like the lips, the tongue, and the larynx. We also know that for speech production, these muscles require low forces but fast speeds to achieve intelligible speech. We actually only need about 20% of our muscular force, but we need fast movements with that force in order to achieve intelligible speech. So we're going to discuss both strength in terms of muscular force and power in terms of using those muscles to achieve rapid, correct movements. And thirdly, from Heather Clark, we also know that we are not able to actively assess for muscle tone in the speech production systems because, as we will learn in a moment, you cannot assess muscle tone in these groups. So let's define these terms, muscle strength and muscle tone. The striated voluntary muscles of the respiratory, phonatory, resonance, and articulatory systems can have both strength and tone. So what's the difference? Strength we define as the force of active muscle contraction. When you decide to move a muscle under your voluntary control, the force that you can produce with that muscle is what we mean by strength. This requires active movement under your voluntary control. We typically assess strength by asking someone to resist a movement. For example, I can assess for jaw opening strength by asking to resist that movement, or tongue strength by asking to resist me pushing against the tongue. It's that force of active contraction. We can assess that. Muscle tone, on the other hand, is passive resistance to stretching. It is passive, and it is a stretching action. It is not a voluntary contraction. So muscle tone is not directly related to active voluntary movement. It's passive stretching. We'll get more into that in a moment. So to understand strength, first we need to remember what a motor unit is, the connection between a motor neuron and a muscle. So motor neurons have primarily alpha motor neurons that connect to muscle fibers in our body. Acetylcholine is the primary neurotransmitter used for muscle contractions. So when an alpha motor neuron releases acetylcholine at the neuromuscular junction, that will signal the muscle fibers to contract. The more muscle fibers there are in a muscle group, the stronger, the greater the force of that contraction. In other words, more muscle strength. So the bigger the muscle, the stronger the force. A second related concept to muscle strength has to do with the innervation ratios. Some muscle groups have high innervation ratios, meaning that for every one alpha motor neuron, there are many muscle fibers innervated by that single alpha motor neuron. One little neural ending going to multiple muscle fibers within a muscle group gives us big gross motor contractions. On the other hand, we also have muscles that have low innervation ratios, meaning that for each alpha motor neuron that ends at a muscle group, only a few muscle fibers are innervated by that alpha motor neuron. This allows for fine motor control. We don't need to move the whole muscle group at one time. We want some intricate control to move and regulate just a few muscle fibers at a time. Muscles involved with speech production are generally going to have lower innervation ratios and relatively small muscle groups, especially as we get into the larynx for intricate control of timing and movement. That was strength, active, forceful contraction. On the other hand, muscle tone, being passive resistance to stretching, has to do not with acetylcholine at the motor unit and alpha motor neurons, but instead muscle spindle receptors in muscle fibers and gamma motor neurons. Essentially, what happens with muscle tone, when a muscle is stretched, these muscle spindles are going to feel that stretch as the muscle fiber is pulled. In response to that, the gamma motor neuron is going to get the signal that that muscle is being stretched and is going to send an involuntary reflexive response back to that muscle to tighten up a little bit. And the stretch reflex is what we're really assessing and talking about in terms of muscle tone. A muscle should get a response that it's being stretched, and involuntary reflexively through the gamma motor neuron send a signal back to tighten up a little bit. When we damage nerves, the peripheral nervous system, spinal nerves and cranial nerves, damage the nerves themselves, we interrupt that ability for that reflex to happen, and that's when we can get low or no muscle tone. Here's a visual depiction of this process. Different neurological pathways, different muscle connections for strength and tone. So here we see a horizontal or transverse slice through the spinal cord, with the posterior shown at the top of the screen and the anterior spinal cord shown at the bottom of the screen. The sensory signals come in posteriorly, have their cell bodies out in the posterior root ganglia, bring those signals into the spinal cord or the central nervous system through the dorsal roots, make connections in the central nervous system, and then the motor cell bodies, the efferent signals, have their cell bodies here in the ventral horns and send motor signals out anteriorly. In terms of a voluntary muscle contraction, the alpha motor fibers are going to get a signal from the brain for voluntary muscle control down through the brain stem, the spinal cord, to tell this muscle, this nerve, to send a signal out through its alpha motor neuron fiber out to the motor end plates, send out through their alpha motor neuron fibers out to the motor end plate to release acetylcholine and cause these muscles to contract. That's a voluntary, forceful, active contraction in red. Completely separate from that, we have the pathway for muscle tone as a stretch reflex. So if a muscle is stretched, here's a muscle spindle receptor on a muscle fiber, and we stretch that muscle, and this spindle is going to detect that stretch. Bring in the sensory signal through its posterior afferent pathway and send a signal over to the gamma motor neuron fiber now, and the gamma motor neuron reflexively, unconsciously, will send a signal back to this muscle that was just stretched to tighten up. Two completely different pathways related to muscle strength, voluntary contraction, and muscle tone, reflexive, passive resistance to stretching. When we damage the nerves themselves in the peripheral nervous system, we will see reduced muscle strength if we can't get the signal out to the muscle fibers, and reduced muscle tone when we disrupt this reflexive signal by damaging the nerves themselves. That's going to be different from upper motor neuron damage, where we will still have weakness, but we will not have reduced muscle tone. Because the central nervous system can also suppress reflexes. And we will learn more about the upper motor neuron system in modules 3 and 4. The extrapyramidal system of the upper motor neuron pathway, I hope you will come back and watch this tutorial when we get to those modules, includes the reticular formation and the red nuclei in the brain stem, giving us involuntary control of some of those reflexive pathways. Your frontal lobes also help to inhibit reflexive pathways, and you can suppress your reflexes if you try, giving frontal inhibition. But in terms of that, what's going to happen when we damage the upper motor neuron pathway in the central nervous system, different from damaging the nerves themselves in the periphery. When we damage the central nervous system, the upper motor neurons, the reticular formation, the red nuclei, the frontal lobes, that's going to cause an increase in muscle tone because we lose the ability to inhibit those reflexes. And those reflexes, like the stretch reflex, are going to become disinhibited and hyperactive, and that's going to cause the muscles to become more tonic, more hyperactive in their muscle tone. And muscles will get too tight when we have upper motor neuron damage. As we learn about muscle tone and increases in muscle tone, you will also need to be able to differentiate between the conditions of rigidity and spasticity. Both of these are conditions associated with increased muscle tone. Rigidity is resistance to stretching that is constant and bidirectional. This is associated with hypokinetic movement disorders like Parkinson's disease related to basal ganglia damage. Spasticity, on the other hand, is also increased tone, that means resistance to stretching, but rather than being constant and bidirectional, spasticity is biased in one direction, and spasticity can be released with stretching. Spasticity is not associated with the basal ganglia, but is associated with upper motor neuron damage and spastic dysarthria. In terms of two primary muscle groups that are affected by spasticity, they are highly endowed with muscle spindle fibers in these muscle groups. The velum and the larynx will show the greatest response to upper motor neuron damage and spasticity changes in muscle tone. Because spasticity is biased in one direction, in terms of the velum with spasticity is biased toward being in a down position. That's going to give spastic dysarthria the quality of hypernasality because passively the velum is going to be pulled down and all that extra air is going to come out through the nose. In addition, in terms of spasticity with spastic dysarthria in the larynx, spasticity is biased toward adduction or closure. So when we get spasticity, the larynx is going to be involuntarily biased toward biased toward closure. And so we're going to get a harsh voice quality associated with spasticity because that's the bias of that involuntary muscle tone. Need a drink. So bottom line, take-home messages. Why do we care about the difference between strength and tone? 1. Strength is not the same as muscle tone. When we do assessment, we can assess for muscle strength with voluntary contractions, but you cannot actually assess muscle tone. The lips and the tongue do not have a great endowment of muscle spindles, so are not greatly affected by spasticity and changes in muscle tone. The velum and the larynx, which are, it's not possible for us to get in there and assess passive resistance to stretching with the velum or the larynx. You cannot stretch them, so you cannot assess them. Weakness is associated with spasticity and flaccidity, but the difference is their muscle tone. Spastic weakness, we're going to get weak strength, but high tone. And in flaccid dysarthria, flaccid weakness, we get weak strength, but low muscle tone. In hypokinesia, we will have rigidity associated with high muscle tone, but there will be no associated problems with muscle strength. So it's important as we differentially diagnose to understand whether there is strength problems or tone problems. As I said, we cannot assess muscle tone in the face or tongue because there are not a great number of muscle spindles in those muscle groups, and you cannot actually stretch the velum and the larynx. Finally, we do have exercises that we can use to try to increase muscle strength for voluntary contractions through resistance and overload for specific movements, but muscle tone as an involuntary reflexive response cannot be changed. So we do not have any active treatments that can alter muscle tone. So that's also why it's important to recognize. Please contact me with any questions. This is commonly confused in terms of strength and tone, and I want to make sure you're very clear on these concepts. So, of course, I'm available for any questions and happy to chat more. Thanks.